Hi, my dear. The navigator. How are you? Hi, my dear. Continue chapter 8. Flow in open canal. Part D. Losses and maintenance. Maintenance of irrigation channel. It is very important to maintain the irrigation channel to achieve its continual water flow efficient all the time and keep it in sequence correction, which is known as healthy irrigation net. There are many variables and reasons which acting for reducing the channel efficiency, such as siltation processes, growth of weeds, falling of sides and bands, and features. Siltation process phenomena may be occur during water flow, especially when water velocity is reduced than the critical one, and so the suspension material starting for deposit gradually on both bed and side. Growth of weeds. Growth of different types of aquatic weeds in any irrigation channel is normal phenomena under favorable conditions and when velocity of water flow is less than 0.5 meters per second. Weeds consider one way of losing water by transpiration process. Moreover, it sometimes creates a harmful material which effect on impairing the normal growth of plants in the field. Falling of sides and bands. Sometimes the continual using of human and animal causing erosion in many spots along wider channels. In addition, this case can be occur also when getting its channel running in full capacity and consequently the water flow velocity effect on its size and height. Pitches, which creation a gaps in different sides and causing a breaking up for sides and bands is a big problem here. Pitches may be occur due to different reasons such as faulty design, overflow of channel, random construction under the pan, furrow of reptiles, and intentionally cutting by the planters themselves for covering their requirements and needs. Losses in irrigation channels. Irrigation channels are usually erected in the agricultural land depending on the irrigation scheme. Losing water from irrigation channels can be occurring by many ways such as seepage, evaporation, and transpiration process. Seepage process is the most significant losing quantity as it is forming the major portion of the water losses in open channels. The seepage losses are mainly depend on many factors such as characteristics of underground table, characteristics of both soil and subsoil layer, design of channel as depth, upper width, high flow, and velocity flow, physical properties of water at its temperature, salinity, acidity, and the quantity of suspended material, and condition of channels as extension, vegetation, and navigation, as shown in the cross table. Evaporation process is little and ranging about 0.25 up to 1% of the total discharge of channels and may depend on both the climatological conditions such as temperature, humidity, and wind velocity, and the free water surface area which is exposing to the atmosphere. Transpiration process is the more little losses which is occurring through the distribution of aquatic weeds which depend on its intensity and the growth progressing in the channel. It is very important and necessary to measure and calculate the seepage rate from a channel net to alleviate the problem of logging and obtaining a good water management control. Losses by seepage can be determined by several methods, such as seepage meter method, which depends that occurring seepage through the pallet fender should cause a corresponding reduction in water content inside the plastic bag during the calculation period. Look by yourself. Ponding method. This method depends on isolating small section of channel and fill it by a known volume of water. Accordingly, the decrease in water section volume during any calculated period will represent the seepage rate, while water balance method is a sample method also, which depends on the differentiation between the input and output discharge for a long reach of channel should be equal to the losses during this reach. Mathematical calculations method. Seepage can be calculated mathematically by following either Etcheverry, Etcheverry and Watson, or Molesworth and Yennidunia equation, corresponding for monthly seepage and seepage rate respectively as follows. Etcheverry equation. Follow it, my dear, by yourself, as shown in the cross equation. Etcheverry and Watson equation. Follow it, my dear, it is so easy in front of you. Molesworth and Yennidunia equation. Follow it, my dear, it is so clear in front of you. Measurements of evaporation losses. Measuring of evaporation losses from free surface water in ohmic channels can be done by using US geological standard open pan evaporator, which has a square shape 90 by 90 cm and 45 cm high. Moreover, using a separated pan has the same intensity and type of the channel gross aquatic width by the same procedure should give the losses by evaporation in addition to transpiration also. Goodbye.